for this video, we are going to have more examples on universal quantification. So suppose we have the statement P of x such that x is greater than x minus 1, assuming that the x are real numbers. In other words, the domain of x is the set of all real numbers. So can we say that P of x is a proposition? So at this point, no, because we cannot confirm whether P of x is true or false. And x has many possible substitutions. Okay? It will only be a proposition once we assign value to x. But given the statement for all x, P of x, given that x is in D, which is the real numbers, a proposition, we can say that it is yes, because this statement has a truth value. But then what will be the truth value of for all x P of x? For this statement, P of x holds true for all x. So assuming x is a negative number, suppose x is negative 1. So negative 1 is greater than negative 2, which is just negative 1 that is subtracted by 1. Okay, and what if x is 0? Then 0 is also greater than negative 1. And what if x is a positive integer like 1? So 1 is also greater than 0. So we can say that for all x, P of x is true since P of x, or regardless of the value of x, this statement x is greater than x minus 1 will be true. Now let's have another example. Let P of x be the predicate P of x such that x plus 1 is greater than x. So what we do here is just add 1 to x and compare it by itself. Okay, so what will be the value of, or truth value of, for all x, P of x, such that the domain is the set of real numbers? Okay, so x plus 1 is greater than x is true for all real numbers as well. So we can say that the truth value of this statement for all x, P of x, or this quantification is true. So why? We cannot also find any real number that will make this false. Okay, regardless of the value of x, whether it is positive or negative, or it is 0, x plus 1 will always be greater than x. Okay? Let's have another example. Let P of x be the predicate P of x such that x is less than 2. So what will be the truth value of the quantification for all x, P of x, such that x is in the domain of real numbers? What we can do is find a counterexample. So what we want to do is prove that this is false. And in order to prove that this is false, we can find a counterexample. We just have to find one example that will make this, that will make P of x false. Okay, and one example is if we set the value of x as 3, and 3 obviously is greater than 2. So the P of x, or the P of 3, is false. So we can say that the quantification for all x, P of x, is false. Okay, now move on to another example. Let P of x be the statement P of x such that x squared is greater than 0. What will be the truth value of the quantification for all x, P of x, in the domain of integers? Okay, that means that we include negative numbers, positive numbers, as well as 0. Okay, this statement for all x, P of x, is actually false. So how can we prove that this is false? What we do is find a counterexample. So suppose that the value of x is equal to 0, then we replace 0 to this statement, 0 squared is greater than 0. And this statement is false because 0 squared is actually equal to 0. Okay? So we can say that the truth value of the quantification for all x, p of x, is false. And now, another example. Let p of x be the predicate p of x such that x squared is greater than or equal to x squared. Determine whether the following universal statements are true or false. We have first, for all x, such that x belongs to real numbers, p of x. And the other one is, for all x, such that x belongs to integers, p of x. Okay, so what will be the truth values of each? So suppose x is equal to 1/2, and 1/2 is also a real number. Okay, then 1/2 squared is equal to 1/2. Then 1/2 squared is equal to 1/4. Okay, and 1/4 is less than 1/2. So we have disproved this statement. Okay, that x squared is greater than or equal to x. So p of 1/2 is false. So therefore, we can say that this universal statement or quantification for all x such that x is in real number, p of x is false. So p of 1/2 is an example of a counterexample. Now, what if the x belongs to integers naman? What would be the truth value of this universal quantification? Okay, actually, p of x is true when x is less than or equal to 1, or if whether x is negative, or when x is 0 or a positive number. So for all integers x, then x squared greater than or equal to x is true. Okay, so if we replace x with a positive number, like let's say 1, so 1 squared is greater than or equal to 1, so it is true. So if x is equal to 0, then 0 squared is equal to 0. And this statement, p of x, is still true. And let's say it is negative. Suppose x is -1. So 1 squared, -1 squared is 1, and it is still greater than or equal to -1, which we can say that it is still true. And so p of x is true for all x in a set of integers. Okay, so we can say then that this universal quantification for all x in a set of integer numbers, p of x is true. Now, what if the domain is empty? So will this statement or quantification for all x in D, p of x, be true? Still, it is yes. Okay, there are no elements in the domain for which p of x is false.